The intermediate value theorem is our first opportunity to apply the concept of continuity. So what does the IVT, as we call this theorem, do for us? We can use the IVT to prove that on a given interval of x, the function will pass through a given y value at least once. If we think of a given y value as a horizontal line, then the IVT will guarantee that our curve will not only pass through this horizontal line at least once, but it will also tell us a general location of an x value where this will occur. So the thing to remember is that the IVT proves two things. Number one, it will guarantee that our function will be equal to some y value, and number two, that our function will be equal to this y value at an x value that is inside a given x interval. Let's look at a picture. In this picture, we see a horizontal line drawn at y equals 1. The intermediate value theorem will help us prove that our curve or our function will cross a certain y value. In this case, we can see that this occurs at 0, 1. Although the intermediate value theorem will not help us determine precisely where this occurs, intermediate value theorem will give us an interval of x values in which the curve or function crosses this y value. The intermediate value theorem states that if f of x is continuous on a closed interval a, b, and if L is between f of a and f of b, then by the intermediate value theorem, f of c equals L at least once, and c is in the open interval a, b. In order to use the intermediate value theorem, you must verify two things. First, verify that f of x is continuous on a closed interval a, b. Second, verify that L is between f of a and f of b. Remember that L is the y value that we're trying to prove is intersected by our function. Verify means that you need to show your work that leads to your conclusion. Why must f of x be continuous on a closed interval? Why not an open interval? Suppose we were allowed to use an open interval. In this picture, we try to prove that our function f crosses L equals 9 somewhere between a and b. Notice that f is continuous on an open interval a to b. Notice also that L is between 2 and 10, and yet f still does not cross L somewhere between a and b. Here we have a contradiction. This is the reason why we must verify that our function be continuous on a closed interval. If we force our y value at x equals a to be brought down and equal to 6, and if our L value is somewhere in between 6 and 2, then the intermediate value theorem can be used to prove that the function crosses this L value somewhere in between a and b. Let's use the intermediate value theorem on a problem. Prove that the function f of x equals x squared minus 1 has a 0 on the interval from 0 to 4. Recognize that in order for f of x to have a 0, it must cross the x-axis. Because the y value where the graph crosses the x-axis is 0, our L must be equal to 0. Now, first show that f of x is continuous on the closed interval from 0 to 4. Because f of x is a polynomial function, it is continuous everywhere, and therefore is continuous on the closed interval from 0 to 4. Now show that L is between f of a and f of b. F of 0 is -1 and f of 4 is 15. 0 lies between -1 and 15. We've satisfied the two requirements to use the intermediate value theorem. Now we can say, by the intermediate value theorem, there exists an x equals c with c between 0 and 4 such that f of c is equal to 0.